optimizing stuff is eliminating stuff, which fits in exactly to the writing simple code. So often code is over complex and doing things it doesn't need to do. Can I eliminate all the recursion? And I couldn't. It was just impossible because of the nature of the language and the thing I was trying to do. So I actually wrote my own recursive shared rewrite knot. I don't know if anyone's done that before. I haven't seen one. I mean, maybe no one's done it because it's not a good idea. I don't know. Why am I learning how to write a C compiler? I want to use a compiler, not write one. But actually, I found it really useful when I wrote my own scripting language for one of the games later on.
Hello everyone, welcome to Wookash Podcast. This time I'm joined by Stewart Lynch, and this must have been the most technical conversation on this show ever. Stewart made 10x editor, 500,000 lines of code making up extremely performant text editor for C++, including implementing his own C++ parser. So without using compiler frontends, LSP, grammar. Besides that, Stewart wrote a bunch of his own tools like Profiler called Frame Pro, his own plugins for a fast file search for Visual Studio, which makes the basis for search in 10x, but also UI library, UI designer from scratch, and solutions for memory management and more. If you want to get good at programming, like seriously good, listen to what Stewart has to say. I love 10x as a name. I think this is like, a lot of programmers get a bad rap of just like, oh, you have this like non-marketing ways like names, and it's like, everything is like very like afraid of being spotted, like, kind of like in the shadow. And this is like 10x editor. You want to be 10x engineer? Here's a 10x editor. This is so cool.
Yeah, I'm glad you think that, because I think some people take it too seriously. It was like I was trying to think of a name, and at the time on Twitter, people were talking about 10x programmers. Do 10x programmers exist? Is there such a thing? And
Yeah.
it was back and forth and all sorts of stupid conversation. So I thought, 10x, that's a name. And even if it's a stupid name, as long as it's memorable, that's the main thing, isn't it? And
Yeah.
I think it is. So it kind of works.
Yeah, and then compare it to like Visual Studio, which is like, if you think about it right now, it's like such a random name. It's like an arcane
Yeah.
name. It's like,
Where
it
does that get?
doesn't
It's like
mean,
visual. So you're looking at it. I mean, what does that mean? It's nothing to do with programming.
yeah.
Yeah.
Okay.
Yeah.
I would like to, before we dive into 10x and how it's built and how it works, can we do like a step back, and can you talk a little bit about your experience? Where did you learn to program generally? Who did you learn from, or from which books? How did you get to the state where you're at?
Okay. How far back do you want to go? That's the question.
How far you think was the like important experience? What I want to do is like to trace back where were these moments where you decided, okay, this level of programming is important to me. I want to get good at it, and how did you do it?
Okay. Well, I might as well start at the beginning then. I started programming about the age of 9. My parents got me a computer for Christmas, and I must admit I didn't know what it was. I'd never seen a computer before, and I thought, "Thank you. Oh, what is it?" And yeah, so it was a bit awkward, but fortunately, I absolutely loved it. And the thing that was significant about it is it came with 100 games, like all on cassette tapes back then. This is mid 1980s. And I just systematically worked my way through all of these games over weeks and weeks. And I was always interested in art and writing and creativity. And I just saw so much creativity in all these games. And I thought, I've got to do that. I had no interest in programming. I was kind of a reluctant programmer. I just wanted to make games and do art and graphics and things. And there was no way to do that. There was no tools back then. So I kind of had to learn basic programming. And so I taught myself from a book over a few years.
What was it then?
Sorry?
What was it as a language technology?
It was just BASIC that came on
Okay.
it was called an Amstrad CPC 464.
Okay.
And, really, really simple language. So yeah, I kind of taught myself everything. and started making games and importantly to discussion tools, because to create games you need tools. Even back then there were no tools, so you had to write your own. So I spent most of my time writing either engines or tools, and never kind of finished any games, I don't think.
When you say tools, you mean like editor, or what do you mean?
Yeah, just like simple editors for sort of creating basic maps that you could go through and
Okay.
things like that.
Oh, okay. Like editors,
Yeah,
not necessarily a text editor, but more like an editor for a game, like a, for
yeah,
example.
yeah,
Okay.
just general game and graphics editors and things like that.
Okay. Okay.
Um, so after that, I guess the next major thing is going to university, where I studied computer science.
Did you
Um,
like it?
I must admit, I didn't. I found it very difficult. Well, the main thing was that I went to a university which is one of the top sort of science universities in the country. I don't know how I got in, because I completely failed my maths at A level, and the jump between A level and university maths is big. Even if you get like top marks, it's really big, and I totally failed. And I found out when I got there that the first year was 80% pure maths at university level, and I was
Okay.
way out of my depth, and I really, really struggled. Um, I completely failed my first year and had to retake, um, but I somehow managed it. And the USD course was kind of full of theory. It was all kind of lambda calculus and the theory of computing and Turing machines, and writing compilers and things, which I thought was all kind of not very useful. I mean, I've been programming pretty much consistently since I was about 9, and taught myself everything I knew. And so I really struggled at university because it was all theory, and
Was this
I didn't think it
Lisp
was very useful.
for
Um,
compilers?
it, God, I-
Scheme?
it's the one with all the brackets and
Yeah, yeah,
and
yeah. So Lisp is
yeah.
generally the name for this like family of languages, right? And then there's
Oh,
like
that's right. Yeah,
a lot
yeah,
of different languages like Scheme and others that would be like Lispy, that would,
yes.
so the
So
parentheses style programming
yeah,
function.
lambda calculus is the kind of thing that all
Yeah.
theoretical mathematical thing that all these languages are based on. So
Okay.
yeah, but funny enough, I did actually find the compiler writing useful. I thought, why am I learning how to write a C compiler? I want to use a compiler, not write one. But actually, I found it really useful when I wrote my own scripting language for one of the games later on, and for 10x editor and C++ parser and things like that. So
Yeah.
yeah, that was the one thing I did get wrong. That was actually useful. But the rest of it, I was kind of, I just wanted to get out into the real world and do something actually useful rather than all this theory
Okay.
and maths and stuff
So
like
when
that.
did you switch to C?
Um, Pretty early sort of 90s, I guess. So it was probably after programming on the in BASIC, and then I got an Amiga 1200 and started programming in C. And again, I just got a book and taught myself how to program in C.
Okay.
Um,
Okay.
and I didn't really, so I was already fluent in C and C++ by the time I got to university.
Okay.
And they didn't actually teach us how to program. And you probably could have got through the whole university course without writing more than a few hundred lines of code. I don't know how some
Really?
people managed when they went out into.
Wow.
Um,
Okay.
so
Okay.
yeah, it was quite funny actually, because I was struggling in university, and I made a real big gamble on the last year, because I knew I wasn't strong in some of the areas, and I decided to completely stop studying in certain areas and put all of my focus on the coursework, which was writing some software. And you could
Okay.
choose whatever you wanted to write. And to me, that was like, oh, at last I get to write some software. And they said that was a really bad idea because nobody gets high marks in software. And I put all my eggs into one basket and just basically didn't study for about half the exams, which was absolutely terrifying, going into an exam with no study and just completely flunking it. But somehow I managed to get enough on my coursework just to kind of straight through and get my computer science degree.
Wow. Okay. Nice. Nice. Okay. What happened when you graduated then?
So after I graduated, I applied to a whole load of games companies, and I got in a place called Climax, um, and that was really good actually. I mean, as soon as I got there, I thought, "I'm home. This is it. These are my people." And I just thought it was amazing, um, and I'm so glad I started at Climax because before I started there, they pretty much focused predominantly on conversions. So they would convert like PC games or even arcade games and convert them onto consoles and things like that. So you had a lot of very sort of old school hacker type programmers who could just jump into anything, and they did absolute magic there to take these games and squash them down into a tiny little console with no memory and no CPU pretty much, and they somehow managed to get it to work. So I was kind of thrown in at the deep end of that, and I've always sort of appreciated that I had that start because the first console I programmed on was the original PlayStation PS1, and I had so little memory and such a weak CPU that every single programmer had to be um, focused on performance and optimization. You couldn't have like a gameplay programmer like you can these days who doesn't know about performance or anything. They just write gameplay code. Every single coder had to know how to make it run fast, whatever you're doing. I spent about 2 years just working on UI systems, and even that is how do I make it run fast and well.
Nice.
So it was a great start.
Nice. This is so cool. Seems so cool. Like I didn't have the job that required focusing on the performance a lot, but this mindset of like, in order to ship things, you need to focus on it. Like, and this, I would love this as a lesson, as a course. So
Yes.
to be done
Yeah.
for 3 months there and like trying to figure it out.
Yeah, to have such tight requirements, which kind of forces you. It's not even like these days you can release a game and it's a bit slow or a bit buggy or a bit sort of stalling. But back then it just wouldn't usually be able to release it. It was like you had to make it run fast enough and everything had to be fast. So everything you did was looked over by one of the more experienced guys and he was saying, "Oh no, don't do that and use this cache and lay out your data in this way." And that was just how we did things. It wasn't I thought that was just programming. I didn't think of it as performance, but now looking back on it, I can see that it was a really good sort of start. Yeah.
Was this, did you learn more from people there or from books and other sources?
People. I stopped reading books before I went to university, really. I just didn't read any programming books
Okay.
after I'm trying to remember if I read any C++ books. I probably must have done. The last book I remember reading was this How to Program in C book.
Okay.
So yeah, not really at all. So
Okay.
yeah, it's all people, and I think that's the best way to learn in a way. So learning on the job as you're doing things from people who really know what they're doing.
Yeah.
Yeah.
And at some point you joined Lionhead, right?
Yeah. So I spent quite a few years at Climax, and well, I was working on an RPG game called Sudeki, and that was coming out about the same time as the original Fable game. So we were kind of competing with them. I ended up being lead on that game, and somehow we managed to finish it, which is an absolute miracle. So that was a very very stressful project. Sort of going to be cancelled every few months. So we worked very very hard, and then after that launched, I kind of jumped ship and went to the competitor and managed to get a job at Lionhead, which was absolutely amazing because they were such a good studio,
Yeah.
you know, and made some brilliant games. Um,
Can you tell me a little bit about Lionhead? Like, whenever now I talk with people that either work there or know people that work there, everybody who says like about the old days of Lionhead, it's like fabled, pun intended, like mystical, lovely experience, super experienced people working there. Like, how did it look like?
yeah, well, I came in, as I said, when they just shipped Fable, so they were already a really sort of strong, close knit team, and I could see that, like they'd worked incredibly hard. Um, and done some amazing things. So it was a real honor to go and work with them. And it was really interesting talking to some of them and comparing notes on how we'd architected the game at Climax versus how they'd done it on Fable. And actually there were some similarities there. Like I think we were the first two studios to use what they now call the entity component system for games. That it wasn't really used back then, and we were kind of one of the first to use that. So I was quite surprised when I went to Lionhead, found out they'd done exactly the same. So we were comparing notes. How did you do this? How many components did you have? Things like that. So yeah, it was really great. And the nice thing was when I got there and they'd obviously decided to start on Fable 2, they decided to start completely from scratch. They throw away everything from Fable 1, do it all from
Really?
scratch. So I was so lucky to be there at the start of Fable 2 to help design the architecture and the game engine and how the assets will fit together and everything like that. So yeah, it was quite an exciting time.
Nice. For how long did you stay there?
I think I was there about 10 years in all. So yeah, I really enjoyed it. I spent a lot of time working on what's called the asset build system. So taking all the assets in the game and compiling them up and packaging them up for the game and everything like that. And that was a huge job. That was really, really big. But I learned a lot from that. So
There's a lot of things like tasks in game development that people don't think about and know about. So either from outside of the industry or from industry, but only using, for example, Unity, right? Like not knowing what happens, for example, like asset packing is the one thing that is like, to me was like, oh, it's not like you just throw in, dump in assets and then you just like ship. It's you need to do a lot of work to do
yeah,
that.
exactly. So yeah, when you write your own engine in-house, it kind of does change everything. It's quite a
Okay.
different world. Yeah.
Okay,
Yeah.
what then happened afterwards?
So eventually I left Lionhead and decided to start up on my own, writing software. And back then I was planning on writing games as well. So I thought, well, I'm a game programmer. I guess I should write games. So I kind of, well, actually, I was quite busy in the first year that I left because I already had a few software products that I'd been working on in my spare time, which were the memory management system, VMem, the Visual Studio plugin FastFind, and my memory profiler called MemPro, which I'd been using on my job as well at Lionhead. And so I thought, right, okay, I'll make these into products and get them out there and see if I can sell them at all. So I did that. And I also decided to work on my game, and which unfortunately I never finished, which I kind of always regret a little bit, but I kind of ran out of money and had to go back contracting. And funny enough, I went back to Lionhead as a contractor, and worked there for like almost 2 years. So yeah, since then I've been sort of contracting on and off, working on my software, and contracting to sort of make ends meet.
Three separate products, a game, and then coming back to contract work.
Yeah, it
It's a
was a
lot
bit
of
crazy.
moving pieces, you know.
Yeah,
What was the game
exactly.
about?
It was a game for like the iPad and phones, and it was like a match 3 game, but it was based on a 2D physics engine. So you had like triangles floating around, bouncing off the sides of the screen, and they would magnetically snap together when the edges came close. And you had to match the colors, and you could break them apart as well. I
Okay.
came up with all these sort of different puzzles. I was actually quite pleased with it, but I'm not very good at making things fun or knowing if they're fun for other people. You know what I mean? I'm more of a low level coder who does profiling and optimization and memory and stuff like that. And I thought, well, I don't really know what I'm doing here. Is it fun? I don't know. So I kind of left that after my contracting.
Okay. So then you contracted to did contract work at Lionhead,
Yeah.
and then this
Um,
this is, by the way, Pure Dev Software was the name
that's
of the
right. Yeah,
company,
that was my
right?
company.
Okay.
Yeah.
Okay.
That was founded in 2014.
Okay.
So yeah, while I was contracting, I actually wrote Frame Pro. So I was doing lots and lots of profiling, and I needed a profiler that kind of didn't exist. And I thought, I'll write one. That's what I do. I write tools. So while I was working contracting full time job, I then evenings and weekends was writing Frame Pro and then using it at Lionhead. And it was a real big success, actually. I was quite surprised because almost everyone on the team started using it eventually, even like producers and testers and everyone. They would use Frame Pro to diagnose. I almost put myself out of a job because they were diagnosing the problems, telling which, it needs to go to this team or that team. And they were just doing it on themselves, which is brilliant. That's what someone who writes tools loves to see, other people just using it themselves and getting the job done. So
How did it do as a product?
yeah, it did pretty well, actually. It kind of kept me going from that time. I started selling it, I think, while I was at Lionhead, and it kept me going until I finished 10x, which was about 10 years later. So yeah, it did
Nice.
pretty well. Yeah.
Nice. So what happens next in the story?
Next in the story.
Yeah.
So Lionhead closed down. Unfortunately, that was really sad for everyone involved. I was kind of lucky because I was only a contractor, so I already had stuff to do, but everyone else had to find new places to go. And I didn't really know what to do. I had lots of ideas. One of the ideas was actually writing my own game engine because I had so much experience in writing engines and editors and assets and everything. I kind of knew in my head how it all fits together, but I also knew how massive a job it would be. And I talked to quite a few people to see if I could get a team together of people to do it. But it never panned out, unfortunately. It would have been interesting, but also quite scary thing to take on.
You mean like a general purpose game engine?
Yeah, like
Okay.
Unreal or something, or Unity. Yeah.
Okay.
So because
as a one person or a couple of person team. Yeah.
Yeah, it's a big project, and I would have needed funding, and would have got very complicated. But I'd worked with Unreal for quite a few years by then, and I was thinking, oh, how could we do this differently? And if you were to start from scratch, it could be so much cleaner and nicer and
Yeah.
everything. So yeah, but that never came off. So I kind of went home and just looked at what I had, and for the game I'd working on, I never finished. I had a UI system, and I spent quite a long time on this UI system, and I was pretty happy with it. And I toyed with the idea of actually selling that as a product, because at the time I don't think there were any real good solutions out there for UI. I mean, all companies kind of did it in house and just cobbled something together, and they were never that good. So I thought, yeah, that could work. I mean, now I think there are quite a few different options of different UI systems, so that's good. But I'd always wanted to write my own code editor. It was always been something in the back of my mind right from the very early days, because I remember back in somewhere around the year 2000, I was using an editor called CodeWrite, I think it was called, and I absolutely loved it because I could customize everything on it, and you could write scripts, and I had it all kind of set up just how I liked it, and I really liked it. But then someone showed me Visual Studio, and I hated the editor, but it had IntelliSense, and I'd never seen IntelliSense before. So it understands C++, and you can do go-to definition and things like that, and that just blew my mind. I thought, I don't want to move from my editor. I love my editor, but IntelliSense, and it's like magic, and because to navigate around huge code bases, you kind of need something that helps you with that, and so I reluctantly went to Visual Studio in a way. It was very sad to leave my old editor because I was thinking at that time, well, maybe I could write my own editor, I could have it exactly how I wanted it. But then when I saw IntelliSense, I thought, well, that's out the window. There's no way I'm writing my own editor because I'd had to write a C++ compiler basically, and no sane person would want to do that. And so I sort of shelved the idea for many, many years. But yeah, it kind of I thought I had my UI system, and I thought, well, it wouldn't be that difficult just to put a text editor, something, a simple text editor in there, and see how it would work. And I had these ideas of um, having like a big workspace where you could place files in physical space and then scroll and pan around. Um, because I thought that'd be so cool, and because I like having lots of files open, but it's frustrating when you can't see them and you forget where they are and where's this? How do I get back to that file? So I thought it'd be really good if I could have a workspace the size of my wall and just
Yeah.
scroll and pan around. So I quickly knocked up a prototype where I could do that, and it was terrible because I just got motion sickness. And I got really bad eye strain from all the scrolling. Text is not nice when it kind of scrolls horizontally.
Yeah.
It's okay when you
Yeah.
scroll up and down, but as soon as you start scrolling horizontally, it was awful. So yeah, I decided not to do that in the end. But I had the beginnings of a really nice, really fast editor, and I thought actually I could do something with this, and maybe other people might even like it as well. But I was mainly just writing it for myself because I still had this idea in my head of I just want the perfect editor, and I was so sick of the editors I was using before who were big, slow, clunky,
Mm.
crashy. Yeah,
Was
and
it more I wanted the editor and build the editor, or was it more I wanted to get away from Visual Studio?
I think equally both, really.
Okay.
I yeah, I was kind of struggling with programming at the time. I didn't know what I wanted to do, and I wasn't really enjoying programming. And I did realize some of that was to do with the tool set, and I just wasn't enjoying using my tools, and that's not a good place to be. So, I thought if I write my own editor, maybe I'll enjoy programming again, and it definitely definitely helps. And when I hear other people say something similar, it's like, oh, it makes programming nice again.
Yeah.
And I've heard that from a number of people, and that just makes my day. And I think, oh, I've
Awesome.
made someone's life a bit easier and nicer. So
Okay.
yeah.
So at some point you took this decision to build 10x editor, and what were the design goals? Or what did you have in mind?
Okay, so the number one design goal was to make it work well with huge code bases, and to be fast and responsive always. Because there are lots of editors out there which are very fast and responsive and lightweight, like Vim or Emacs or whatever. And they're great, but they don't always have everything else like the C++ parser or anything built in. Um, so you have small, fast editors that don't quite do everything that I wanted, at least, or you have big, sort of bloated editors which do everything and more, but they kind of tend to fall over on really huge code bases. I'm talking like 10 million lines plus. Um, and in the games industry, I've only ever worked in the games industry, so I don't know other industries, but I don't think there are that many companies have it with that big a code base, millions of lines of C++ code, complex C++ code, and
Mm.
where you have to manage all of it, not just a bunch of libraries bolted together. So I think in some respects, games industry might be unique in that sense. I'm not saying there aren't any, but I think most games companies have this problem where their code editors don't always cope with what's thrown at them. So yeah, that was my number one goal, to work on big code bases and to be absolutely blazingly fast and responsive, and to understand C++ out of the box. I didn't want any kind of, oh, you've got to set this up, you've got to download this, then you've got to plug these two things together, and then you get syntax highlighting, and then it might work or it might not, or it might be a bit buggy. I wanted everything where you just open it up and it's there, it just works, and you can rely on it. Um,
Okay.
so
How? Okay. But C++ has this unique positioning where it can be built in like hundreds of ways, and you want it to be just working in terms of you open up and it works. So how does this fit in to this design goal of just working?
Yeah, that's the difficult bit. C++ is an insane language. It's just crazy, which is why I originally never wanted to write a parser for it. Um, but the way it started is I thought, well, my use of C++ is very, very simple. It's basically C with classes and not much else. And I thought I can write a very simple parser that understands where a class is declared or where a function is declared. And then, I mean, how hard is it to parse a class definition, class, keyword, open brace, etc.?
Yeah.
Anyone can do that. It's really, really simple. And I thought, well, at the very least, I can do that. And maybe I can parse a function and do that. And it won't work well enough for all C++ because that's a crazy goal, but it'll work well enough for my basic simple C++.
Okay.
So I thought, yeah, I could do that. So I thought, okay, I'll give it a go. And I just wrote a really basic parser. I mean, it, it's not like a compiler at all in a way. It's quite a different beast because, as I said at university, I'd written a basic C compiler, and for Sadeki, like I said, I wrote the scripting language that all the gameplay was written in, which was like a very it was like a bit like Lua, but a bit more basic C like. So it was it compiled it into bytecodes and things like that. So I've written a proper grammar for the language. So I understand how to write a proper compiler, and I threw all that out the window and thought, no, I'm not doing that. I don't want to write a language, grammar for C++. That's crazy. So, like I said, I just did the most basic thing. Sort of wrote it all in code. It didn't have any language stuff. Um, and yeah, it worked pretty well for basic stuff and worked quite well for my code. And then I've just literally been adding to it since then. And I keep on thinking at some point all of this has got to fall over and it's all got to break. But every little, I think, can I just make a tiny step forwards and another tiny step forwards? And can I parse after the classes and functions? I thought, well, I really need scope. I need to know what scope a function is in, what class is in, or namespace. So scope is just a curly brace. I can do that and count them, and you get scope. And then I thought, well, can I do a simple template? And yeah, I can do a really basic template and pass that. And it
You
just
are
kept adding.
convincing yourself that you can do it with each
Yeah,
step.
exactly. If I'd known what I've got now, I would never have started. But as I was just incrementally adding to it, I thought, yeah, this is actually going really well. And the nice thing is, it was really fast and it didn't rely on any compilers or build systems. I'm literally just parsing the C++ source file. So that's all I have to worry about. I don't have to worry about any other complexities. Um, and the nice thing is it works consistently 100% of the time. It's not because when a lot of other editors use like compiler front ends to compile into syntax trees and things like that. And the problem with that is when you're writing a parser for an editor, the code's changing all the time, and you've got to update the syntax tree as the code is changing. And that's quite a different problem than writing a compiler. A compiler, you can just flag up an error and throw up your hands and say, well, I'm not parsing this rubbish, fix this error on line, whatever. Whereas you can't do that with a parser for an editor. You need to keep going and keep trying to parse stuff that you can. So even though I didn't have complete coverage of C++ as a language, the coverage I did have was totally consistent and would always work. It wouldn't break if you put an error on line 10, it wouldn't break halfway down the file because the compiler just got all confused and gave up. You know what I mean?
Yeah, but so what did you do for your parser then? For these uncompleted lines,
Well,
incomplete
the
lines.
parser, it basically, so I write a function which is like parse a class. So it says, well, okay, it's the first keyword class. There's a second keyword. Sorry, it's the second token, a keyword. It's the third token in the open brace. Um, and I would do that for all the sort of permutations of how you can declare a class. And I would do that for every kind of thing, like a member function, sort of an inline member function, a function definition or declaration. And I would just have a function for all of these different things. So it would just look ahead as many tokens as it liked. Um, and just match whatever it could. It didn't really care about language, whether it made any sense at all. It just say, does this look like a function? Okay, yeah, it's probably a function. And so it's a very
Okay.
loose compiler. It just kind of does the best it can just by looking at the code it's got.
Okay. So if you had like an incomplete line, the beginning of the function definition, you would just go as far as you can, and at some point you would just stop, and that's it.
It would, so it won't parse it until it's got the complete function definition, say up to the open brace for the
Okay.
function. So as
Okay.
soon as you completed that, then it matches the whole thing and says, yes, this is the function. If
Okay.
it doesn't do that, it will just go to the next token and say, does this look like anything I recognize? You know, is it
Okay.
is it
So
a,
it skip it.
so
Okay.
it
Okay.
would just skip anything it doesn't understand. It would just skip, and every token it would say, what does this look like? Oh, I think this is the variable definition, and things like that.
Okay.
And it's a really sort of simple and basic way of writing a parser, but it actually works really well. And it's very consistent, and it's really good for updating code. So when code is updated, say I just change a few lines of code, the parser will actually just literally reparse those few lines of code just by looking at the tokens it's got and saying, what does this look like? So whereas like if you were using a compiler for the editor, it would have to compile the whole file again and try and make sense of everything in the file. Whereas my parser can just pass a few lines at a time, so it updates instantly as you're typing, which is really nice.
So when you started, there was no LSP, Language Server Protocol. Now with, for example, NeoVim or other like editors, you can have a like VS Code, you can have like LSP, and on one hand, there is a editor that knows how to talk to it, and then there's the language server for each language, right? And this is what gives you like the definition, references, and stuff like that. Have you managed to compare the speed between your parsing, for example, and the LSP? How would this look like?
I've never actually used it. I've never looked into it. I think it was around when I started the editor, because
Oh,
people were
really?
saying to me, "Oh, why don't you use LSP?" And
Okay.
I was like, I don't know, maybe, but I didn't have any experience with it, and I have a basic mistrust of any large software libraries I have to use. So I thought, well, even if it is the best option, I don't want to do it. I want to write it myself. And I have this just philosophy where everything I can write myself, I will write myself. And I've
Okay.
always done that. And it's not always the best option. Obviously, sometimes there are things out there you can use. Um, so I mean, any sane person would have looked at it and compared it and thought, I thought, "No, if it's the right answer, I don't wanna know because I don't wanna use it, because I know I'll spend the next 5 years fighting with it, trying to make it do what I want it to do, and, you know, dealing with edge cases and bugs, and
Yeah.
also it's in someone else's hands how
Yeah,
good my editor is."
it's in the hands of the company that brought to you
Yeah,
Visual Studio, so
exactly. So, yeah, I didn't even bother looking at it, but I have heard a lot of people say they're so glad 10x doesn't use OSP. So I assume they've had experience with it and know how kind of it's maybe not as robust or consistent as it could be.
Okay. Can we take a step back and can you paint the like high level paint the picture of high level architecture of 10x? Like generally speaking, what text editor needs to function?
Um, well, I guess the first main component is the UI system, which, as I said, I wrote from scratch myself. And then obviously you've got the C++ parser. That's the biggest part in terms of probably code and the amount of time spent on it. I probably spend about 80% of my time on the parser.
Okay.
The actual editing of text was almost an afterthought. It was like, oh, just throw something in there, it'll be fine. So there's not that much interesting technology in there. I just did it in a very basic way, and it's really hard to make a text editor that's slow if you make sense of all this.
But it's still you're doing like a renderer for it, right? You have
Yeah.
glyphs and you're doing like all of those parts. So in my mind, like a renderer is like a separate piece of the text editor. So if I were to make it from scratch, I would need to think about the renderer, right? And the UI components, C++ parser. What else is there?
I think that's it really. I mean, there's not much else to it. You know, there's all the low level systems like the memory management, the file system,
Yeah.
all that core systems. I think that's really it. But the renderer, I was using the renderer because I'd kind of written a game engine for my game, so I was using renderer for that, which rendered in OpenGL and DirectX. You could kind of switch between them, and I started off in OpenGL and then went to DirectX. But at some point, actually, it wasn't that long ago, I ripped out the entire renderer and just replaced it with one text file with like a few hundred lines of code, which is the DirectX API calls. And that was such a nice feeling of just throwing away, oh, I don't need all these matrices or this 3D code or the camera code or
Yeah.
this. I just threw it all out and ended up with just one file. And I was just so pleased because I upgraded to DX11 because I was on DX9, at that point. So I know 11 is still considered old now, but to me that's like modern.
Yeah.
Um,
On the renderer part, you need glyphs, right, for the font. Can you paint a little bit of a picture? How does the font rendering, generally speaking, works?
yeah. So I do actually use a library for font rendering, which is FreeType, which can load in TTF files and create glyphs from the font. So I basically just create one big texture page, put all the glyphs in there, pack them in, and then use that. The renderer, like I said, very basic, but the one thing it does do is batches things together. So in my UI system, every object renders itself. It is the sort of classic object-oriented type approach. So every object renders itself, but all it does is does a mem copy, copies its vertices and indices into one big vertex and index buffer for the entire scene. So
Okay.
it's almost like rendering a particle system where you just have one big buffer and then you just chuck loads of things in it, and then you do render. And the nice thing is, if you're, say, each line of text copies itself into this big buffer and it's all from the same font, then you only need one draw call for all of it. So
Yeah.
anytime the state changes to, say, a different texture or any clipping or something like that, then it'll flush that draw call, start a new draw call, and then build that up until it's there. So it can render the whole scene in just a few draw calls, which is really nice.
Nice. Okay. You mentioned that you use a bare bones C++, like a C with
Mm.
a couple of additions. Can you walk me through what do you use and why you don't like C++ standard library and newer additions?
Okay. Yeah. I think I'm still stuck in the sort of 1990s of C++ in a way. Um,
You're not alone.
yeah, I hear that quite a lot now, which is nice. People are starting to realize that some of the new fancy stuff isn't all that great. So yeah, I never, when I first looked at SDL when it was first, because I mean I started on C++ before SDL existed, so
Oh,
I didn't have it. You had to write your own stuff, or at least I didn't know about it. I don't, maybe it did exist in a sort of small
okay. I
way.
didn't know there was a period of time where there was a C++ for this. To me, it was just merged. Okay.
I really can't remember. It may have been, but at least I didn't know about it or use it, and nobody did. So yeah, it was just like C, but you could do classes, and I thought, well, that's cool. Because the way I used to write C, I would lay it out in files and compartmentalize things like that, and pass in the this pointer manually, basically. So I was basically doing classes in C. So when C++ came along and said, "Oh, you can just do it like this," it was kind of almost a straight move over. So I kind of quite like that, and that's kind of how I've always done it. Um, and then templates were added because C++ didn't have templates at one point, and And I, just like everyone else, went crazy with templates and templated everything. I wrote this particle system, and somehow, I don't know how, I managed to write templates everywhere in this part. It was a particle system. It's like, how simple can you get? You don't need templates in a particle system. But somehow I managed to do it, and it was terrible. And that put me off templates for life, I think. I kind of don't. I mean, the only thing I use templates for now is container classes, basically, or allocators. So my core library, I'll write on my own container classes, arrays, maps, hash maps, etc., and my own allocators. And I use templates for those, obviously. And I think that's the only place I ever use templates now. So yeah, they have their uses, but sort of don't go crazy with them. And I never liked STL from the start because just look at the code; it's terrible. And if you have to debug it, and I've spent so much of my career in the games industry fixing the worst horrible bugs. I got known for being able to somehow fix crazy bugs that nobody else wanted to touch. And so many times you get a memory overwrite or something, and it's deep in STL, and you've got to dig through all these templates, and it's terrible. And most people who use STL don't know what's happening under the hood. They don't realize all the allocations that are happening every time they do something, and so to me, it was just it's a slow library. It's over complex. It tries to be too generic to be good for everyone, but it's really not that good for anyone in a way, because and the thing is, if you're a serious coder and you're gonna write your own code, say you're gonna spend the next 10 or 20 years writing your own code, you can spend a few days writing an array class or a map class or a hash map. It's such a no-brainer investment. It's not like you have to spend the next sort of 5 years writing STL, because that's what a lot of people do. They say, "Oh, I'm not gonna use STL. I'm gonna write my own STL, and it'll be much better, and I can do better than all these clever experts can do." No, you can't. It's bad because the design is bad, so don't try and rewrite STL. Write your own container classes, just the ones that you need, make them as simple as possible, have as few templates, and have as shallow hierarchy as possible. And you can easily see what's going on in the debugger, and you can tweak and change things if you want to. So I would highly recommend any serious programmer write your own container classes. It's not a big deal, and once you've written them, you never have to touch them again. So yeah.
This is a technique coming from, I think, C developers. That like uh, every time when I speak to somebody like you have like your own layer of utils that you like carry over, right? Like if you're not coming from a C world, like I come from Java, it's like I don't carry my layer of utils. Just that like I use the JDK, so like the standard library, right? What it provides, but you just seem to carry your own abstractions like from the project to project. So what is in your layer of things that you need to always have in your pocket?
Yeah, that's a really good point. You do end up sort of carrying these from project to project and using them in various different places. So obviously I've got the basic types like, arrays, and I've also got a sort of red black tree map class, which isn't very performant, but it's still more performant than like the STL one, for example. But it's because the nice thing, like say, even with the map class, you can lay out the memory so it's all contiguous memory. You don't have to do an allocation for every single node in the tree. Just simple things like that can make it perform, 10 times better than just a basic implementation. So yeah, I've got things like map sets, hash maps. I've got a number of different hash maps. Um, and what else I've got? Oh yeah, my function class, which, because I don't use lambdas, okay, so I just have never liked the syntax. I think it's totally ugly, and it's not very performant because it does too many allocations for my liking. And also I needed I needed it before lambdas even existed. So I've got my own function class where you can, store function pointers and the I forget what it's called, like the arguments. You're going to pass in, and it can package it all up, and then you can sort of add to function lists, so you get events that can fire and fire off to multiple places, things like that. That's probably the only place where I've done some really crazy template programming, writing my own tuple class and things like that. So that was kind of fun to do as an intellectual exercise. It was kind of fun. And I'm really glad I never, ever, ever have to touch it again, because it just works. But I really love it. It's great. I can do Lambda style programming, but without the Lambdas, and I know exactly how it works, and it performs really well. I think that's probably about it. Let's just have a look.
It's a different kind of hash maps. In my limited worldview, there is a hash map. So what can be different between hash maps?
Okay, so my main hash map, I don't even know what it's called. I'm sure there's a proper name for it, but I was taught it back in my days of starting off at Climax with the old school hackers. And they just said, right, all you have to do is just allocate one huge array and then mask off the hash that you've created, and just stick it into that big array wherever it happens to land.
Okay.
And if you have two that collide, you just add one to it. So it's the most simple basic hash map that you can imagine, but it
Okay.
performs, in my experience, better than any other bucketed type, because usually hash maps are bucketed, where you have lots of buckets and you chuck into a bucket and things like that. But then you have to allocate those buckets, and they might be anywhere in memory, and
Yes.
there's an extra indirection in there. Whereas if you do it the way I do it, it's having one big array, and then all it is just a mask and a lookup in an index. It's very, very quick. As long as your hash function is good, it has to be really good. Otherwise, you have lots of collisions, and then you keep because if you have, say, 5 collisions on the same hash map entry, you obviously have to check 5 different elements until perhaps you find the one that you wanted. So you've got to have a good hashing function. But
Well, how big is this array then, usually?
well, it's usually a power 2. It doesn't have to be power 2. I always like to make it power 2 because that gets rid of one instruction or something. But it usually has to be about so 4 times bigger than however many elements you've got in the hash map. So if you've got 25 elements you want to put in the hash map, it has to be a size 100. That's the kind of sweet
Okay.
spot that I found, where you get some collisions, but not too many collisions.
Okay.
And then obviously if you run out of space, it just resizes and inserts everything again and gets bigger. So yeah, I mean, it sounds like a lot of memory, but when you compare that to the bucketed system where you've got loads of buckets and they all might just have one thing in, you end up with almost a similar memory overhead of a normal hash map. So
Okay.
the benefit is all this memory is just in one contiguous chunk, and it's much more cache friendly.
Okay. 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 We ventured off 10x a little bit. Do you want to highlight any of the C++ features that you don't use or use, or we can come back to 10x editor?
Yeah, I'm trying to think if there's anything else I use other than classes templates. Well, I started using the range-based for,
Oh,
which for me was like a big thing. I was resistant at first. Oh, no, this is new. I don't like it. But actually, yeah, it is quite nice. It makes the syntax a
but
bit simpler.
you need then like STD vectors, right, or other things.
No, you
You
can
have
write
your
your own
iterators.
iterator. So yeah, you
Okay.
just put an iterator in your class which conforms to a certain standard, and then it will
Okay.
just work with range-based for. So that was one thing that I added from modern C++.
Okay.
But yeah, I can't really think of anything else I use from modern C++. I'm sure there are a few things, um, but yeah, that's probably about it.
Yeah, I've seen your code on the streams. And by the way, for everybody who is listening, go watch October 24th, 2020, first stream of the 10x editor development. There's so many cool nuggets of knowledge and how to think of a huge project written in C++, how to maintain this in memory, like all sorts of cool tricks. You're just dropping them off the hat, like so many good stuff, really.
That's good.
And so your code looks really simple, and this is super cool. Like
Yeah.
it's not like complex. It can follow what is happening. It's a super
Yeah.
cool feature.
I like to write code that a person who has just been learning C++ for a few months, like a couple of months, that they could look at and understand what's going on. You know, they may not be understand the entire project as a whole, but they can just read every kind of function I do, and it's just simple. And I don't try and pack things in. I think a lot of programmers like complexity, and I think that's a real problem because I think a lot of programmers get into programming because they have the mindset of, oh, I like complex things and I like solving complex problems. And as I said right in the beginning, I was a reluctant programmer. I didn't actually want to program. And in a way, I still don't. I want to write as little code as I possibly can. And I want to write code once and never look at it again. I don't like complexity. I'll rewrite code many, many, many times to get it as simple as possible. It's like a lot of people say, "Oh, it works. I've done it. It works." Well, no, it works, but could it be simpler? Rewrite it, do it again, make it simpler. Because I don't want to have to maintain a whole load of code. Because one of the biggest problems with 10x is it's so big. It's like I've written myself about 500,000 lines of code, and to hold that in your head and maintain all of that. I mean, in a normal company, you wouldn't have one person maintaining 500,000
Oh
lines of
yeah.
code. It would be crazy. Even for me, it would be impossible because in a normal large code base, it's usually old. It's got lots of legacy code. It's been worked on by hundreds of programmers over a 10-year period. Half the programmers have left the company. I mean, I've worked on code bases where no single person would dare tread in a certain area of the engine. It's like nobody knows this code. I mean, I go into a company when I'm contracting. I ask, okay, who owns this bit of code? Oh, yeah, I need to fix a bug in it. Or don't go there. We don't go there. Dragons are there. It's like you know, and it just stays for decades. It just code stays there, and you spend most of your time on the big code base at a big company just trying to figure out what the person was thinking when they wrote the code. Not necessarily that it's bad, just that they've written it in a way that you might not write it, and you have to work out, oh, I see they think like this, and you spend most of your time just maintaining other people's code, and that can be very demoralizing if you're just
Oh
doing
yeah.
that for years and years on end. So the only way I can maintain all the code that I do, well, two things. One, because I wrote it. So even if I forget how something works, I just say, oh, how would I write this if I was going to write it? Oh, I did write it. Oh, it's written how I expected it. Oh, that's nice. And it's just so easy and it's so nice. So that's the main reason I sort of quit working in companies and wanted to work on my own stuff because I just want to work with my own code so that I know how it works. And the other thing is that allows me to maintain this big code base is everything is as simple as possible and as minimal as possible. So I can't afford to write huge complex systems that are over engineered and hard to maintain and buggy. And I have to make it absolutely streamlined and minimal. So all the code is as I expect it and hopefully not over engineered and sort of easy to maintain. And it's been the most difficult thing about 10x, trying to hold all that in my head. Even with all that said, it's still a lot to hold in your head. Um, but it's also the most rewarding thing because it's so nice working with just your own code. It's like then to add new features is so easy oftentimes. And I often think, oh no, this feature is going to take sort of weeks to do. It's going to be really difficult. And I'm sure I'm going to come across loads of problems I didn't expect. Because when you're working on a big code base in a company, there are always so many unknowns. You think, oh, this will be easy. I'll do it really quickly. But then you think, well, to do this, I had to completely rewrite this system over here because it's not as I was expecting it was. And it turns into a massive, massive task. So I'm so used to that mentality. But when you're working on your own code base, that totally changes. And I'm now finding, after spending so many years writing all this code, I can add features really easily and they just slot in. It's like, and it just works. And I'm like, I thought that was going to take 2 weeks and it took 2 days. And it's such a nice feeling. That's like all that hard work of doing all of the code myself. And everyone's saying I'm crazy doing it all myself. All that paid off. And it's easy to fix bugs. It's easy to add features and it's really fun and nice to work in my code. But yeah, it was hard to get here. So, but now
Like
I'm here. It's nice.
hard and long, right? 10,
Yeah,
10 years.
I know. I think I worked on 10x for about 3 years. And I thought, this is crazy. It's going to take 10 years to do. And I thought, I don't want to work on a project for 10 years. Why would I do that? Because I don't even know if it's going to work. I don't even know if anyone's going to like it. So I'm not going to do that. And I was about to quit and maybe even quit programming and try doing something else. It was a difficult time. And then COVID hit. And I thought, well, I can't quit now because I can't get out and find another job or retrain at university or anything because we're all in lockdown. So, okay, the universe is telling me I need to carry on. So I thought, okay, while COVID is happening, while we're all locked down, I'll just get my head down and carry on working. And what I did was I just gave it to a few people who follow me on Twitter just to see if anyone else, because I'd never shown it to anyone after 3 years, just to see if anyone else would like it. And I got some really good feedback and people got what I was trying to do. They said, yes, I've been looking for an editor like this for ages. And they totally got the performance aspect of it and everything else. And that gave me sort of confidence to carry on. And so I just carried on and I got lots of really great support from people. And I started up a sort of beta program where people could give a small amount each month. And that kind of helped keep me going. So yeah, I'm totally grateful for all those people who supported 10x right in the beginning. And I was wrong. It didn't take me 10 years. It took me 7 years. So it was I think I worked on it for about 7 years before I got to version 1.0 and was able to release it. But that was such a hard time because even though I had people following me and they liked it, it was still only a few hundred people and I needed more than that to make it into a business. So I still didn't know, even after 7 years work, would it actually work? Could I make a living off of it? So it was pretty stressful, I must admit.
Let's come back to 10x a little bit for the technical questions. How do you use resources efficiently in an application like text editor, like in terms of like threads, CPU, memory? Like how do you do that?
Yeah. So the parser is highly threaded and some of the most insane threading code I've ever written. Some of it I'm not very proud of. It's quite horrible. But it's horrible because it has to be in a way. So if you think of a compiler and a linker in C++, the compiling stage is quite easy to put across multiple cores because you can compile each file on its own and just compile lots of files at once. So that's kind of the first stage of the parser. That's not too bad. But then the linker phase of the parser is where the linker has to know about all the logic and syntax hierarchy of all of the files together. So you've inherently got a problem where if you want to use multiple threads, they're all going to be wanting to access the same resource at the same time. So the parser had to be multi-threaded because otherwise it'd be far too slow. So it's essentially like writing a multi-threaded linker, which is a really hard thing to do. And there are lots of locks in there, and I even had to write my own locking primitive to get it all working, which
Really?
was a scary time because I make heavy use of what's called a shared read-write lock, or a slim read-write lock in Microsoft terms. So that allows multiple readers to read the same bit of memory at the same time, but only one writer. So if you're writing to the memory, you have to stick a write lock, and that stops everyone. If you're reading from memory, then you can read at the same time as lots of other people are reading, as long as there's no one writing. So I use the shared read-write lock a lot because in the parser, a lot of it is just reading. Lots of things are reading lots of other things in different files and places. And there's not that much writing. So it makes a lot of sense to use a shared read-write lock. But the problem I had was these shared read-write locks on Windows are not recursive. And so once you've entered it, you can't enter it again on the same thread, or it just completely locks up. And it's one of the limitations of them. They're really fast and light and they're good, but they're not recursive. And if you can imagine a parser which has to jump around lots of different files. So say you've got a symbol and you want to know what it is, and you had to find what it's indirected off of, and then you had to find what that class is, and then you find that's got an overloaded indirection operator. So you've got to resolve that type, and then that type is a class which inherits from something else, etc. You get the picture. You're jumping around lots of different hierarchy trees and everything. And what I found was I was getting lots of recursion. So it would just hit the shared read-write lock and stop dead. Everything would lock up in the parser. And I was trying to think, because I mean, usually you don't want recursion when you're locking. Can I eliminate all the recursion? And I couldn't. It was just impossible because of the nature of the language and the thing I was trying to do. So I actually wrote my own recursive shared read-write lock.
Okay.
And I don't know if anyone's done that before. I haven't seen one. I mean, maybe no one's done it because it's not a good idea. I don't know. But I knew I couldn't make this parser work if I didn't write this thing. So I had to write it, and it's a tricky, very tricky thing to do, to write any kind of locking primitive, because there's so many weird edge cases that you can get to.
But did it work as expected? Like you
Yeah,
got the recursiveness and also the ability of this shared lock. Okay.
yeah, it did eventually, but it was a scary time because I wasn't sure if it's possible, because some of these locking mechanisms, it's just not possible to do something. I thought maybe no one's done it because it's not possible. But fortunately, it was, and it's worked ever since. So I haven't come across any
Nice.
horrible, nasty
Nice.
bugs yet. So that's good. So yeah,
Nice.
that's the threading aspect. That's with the parser. In terms of memory, I do a lot of using my own allocators and laying out memory in large chunks. So like what I call an incrementing block allocator, which just every time you allocate, it just increments an index into a big buffer. So like when the parser reads in its cache of data, so it's done the full parsed your entire project. The next time you start 10x, it will just read in the cached file. And it's reading in lots of different classes and symbols and hierarchies and everything. And everything goes through this one allocator, which just increments. So it's all consecutive in memory, and that makes accessing all this information really, really fast, rather than it being scattered everywhere in memory. So yeah, that's how I like to use memory in cache-friendly way.
Okay. Okay. Uh, have you, how often do you compile 10x and then need to drop into assembly to look at the actual instructions and optimize on this level?
Hardly ever, to be honest. I don't think I've ever had to do that. I've never gone into assembly. The only time I do is when I get a crash bug or something, and I'm trying to work out,
Okay.
what's happened and what's gone wrong. Um, I mean, I mean, really, I haven't done any kind of assembly work for probably more than 15 years, because the way I write C++, I write it in a way that allows the compiler to optimize it really, really well. I don't do things which thwart the optimizer and confuse it and stop it from doing something. So I very rarely have to ever go to that level. I mean, the compilers these days can do things beyond the human mind a lot of the time. It's just you have to be very, very good assembler to beat the compiler at a lot of things. But yeah, I can do it, like I said, and if I have bugs, I sometimes have to drop in and start reading assembler and stuff. So it's not like can't, it's just I don't find I need to really. I never, you know, when I optimize, it's almost always at a higher level. And I found this so many times because I mean I spent most of my career optimizing and profiling. I'm known as the memory guy and the optimizer. That's just what I do. I make games fit in memory, and I make them run fast, hopefully. And I very rarely have to drop down to that low level, because what I do is I look at the structure as a whole and the higher level, and I say, well, does it actually need to do this thing? And so often optimizing stuff is eliminating stuff, which fits in exactly to the writing simple code. Um, so often code is over complex and doing things it doesn't need to do. Or you can just subtly rearrange things and get huge performance wins. And I can often get much better performance wins than other people focusing on the assembler, and they're trying to get the odd instruction back. And I'm just saying, well, I just saved a million instructions by not doing the thing at all. It's quite a different. I remember on one game, there was this huge nested if statement of about 15 or 20 nests deep, all
Okay.
checking different things. And it was in this really, I won't go into details because it's, NDA'd and stuff like that, but it was doing a very, very complex heavyweight thing over a number of frames and taking a lot of time. And I profiled it with FramePro, and I was just manually putting scopes in and checking each level of this if statement. And I found one of the checks was taking a really, really long time in this big nested if statement. And I realized that it never got hit if the if before wasn't hit, or the other way around. I can't remember. And all I had to do was swap these two ifs and do the simple one first, and only do the expensive if the simple one succeeds. And I found the simple one never, ever, hardly ever passed. So it
Yeah.
never had to do this expensive. So I just switched two ifs around, and that was the biggest optimization I think I've ever done. And and it's something that, unless you stare at the code for hours and hours and hours, you probably won't ever see. So those are the optimizations I absolutely love, because when you find something like that, it's like striking gold. It's a really good feeling.
Is this a good time to talk a little bit about Frame Pro and how it works as a profiler?
Yeah, sure. So FramePro is a um, instrumented profiler, and so you've got basically two types of profile. One is a sampling profiler, which just does random samples. The other is an instrumented profiler, where you have to put scopes in yourself, or it automatically puts scopes in for you and measures like how long did this function or this block of code take to execute. Um, so it's a manual instrumented profiler. So you put in these FramePro scopes on places where you want to know exactly how long the code is taking. And the reason I wrote it is because at the time there wasn't really a profiler which was real time. And what I wanted, I was working on some of the Fable games at the time, and it would be very common to have the case where you'd have to play the game for half an hour, and then there would be lots of spikes in the frame rate, where frames would take a very long time. And you don't know when that's going to happen, and what I wanted was to be able to attach a profiler in real time while the game is running and see the profiler updating each frame, so you can see the frames whizzing past in the profiler while you're actually playing the game over here. And then it's very easy to just say, oh, we had a spike in the frame rate, something glitched, and just look over to the profiler and pause it and say, oh yeah, that frame was a big spike. Click on that frame and it gives you a breakdown of everything that happened in that frame that you've already scoped. And again, the profiler had to be very optimal to be able to do that in real time, because most profilers can't do it in real time. They'll you say, okay, turn the profile on now, and then you've got to play the game for 30 seconds, and then it creates this massive 2 gig file, which you've got to stop, and then you've got to load up and read, and that's no good for an interactive game where you're running at 60 frames a second over half an hour game periods. It's like, that just doesn't work. You don't catch the things as they're happening. So that's why I wrote it. And like I said, it turned out to be really, really useful.
How did you do it so that it was so lightweight?
Yeah, that was the tricky thing, because the thing about most profilers, and this is why I've never really used profilers, or at least not instrumented ones, because so often the profiler affects the thing you're profiling.
Yeah.
So what a lot of profilers do, instrumenting ones, if they're automatically adding timing scopes around every function, for example, and you've got a function which is nested deep in four loops and being called millions of times a frame, and if that one function now has a get time at the start and a get time at the end and measures the time and then adds that time to some list somewhere else in the profiler, that function is going to look really, really expensive, when before all it was probably doing is a few instructions, and it wasn't expensive at all. But as soon as you put those scopes in, it looks really expensive. And I've seen people using these profilers, and they just turn everything on in a profiler and think, oh, I'll measure everything, put scopes everywhere, and I'll run it. And they say, oh, that function there is taking a huge amount of time, I'll optimize. And they spend ages optimizing the assembler, trying to get that function really fast. And then they finish and they take the profile off and they run the game, and it's no different. It's like, what happened? And I saw this over and over and over again. People would be optimizing the wrong things because they didn't understand that the profiler was actually changing the thing they were profiling. So the nice thing about Framebrew, even though you have to add scopes manually, you can choose where you want to put the scopes. So you wouldn't choose to put the scope in a function that's being called a million times a frame. You would put it on the outer scope. So yes, it takes a little bit of time to add the scopes, but once you've got them, you can trust the result. And FramePro will actually tell you if you put too many scopes in and it's not accurate anymore, because it's just measuring itself, basically. It's measuring the time it takes to add all these scopes and get the results and do all this. So yeah, it was quite hard to make it optimal. It was, I don't know about how, it wasn't hard, but it was tricky. You had to be really careful that you didn't add anything to the profile that would cause a stall, and that every time you get a scope, you just add it to an incrementing buffer, and when that buffer gets to a certain size, you flush it off to the network layer that then sends it over to the profiler.
Okay.
So in a way, it's very simple, but it was quite tricky to keep it simple and keep it stall free, so that the profiler isn't stalling the game at all.
How big are the buffers?
Not that big, probably, I don't know, 64K or something. So because it's constantly flushing the buffers over the network connection,
Okay.
and as long as FramePro on the app side is picking up that data consistently, because that was the other thing, that the actual app has to process this data so that it can keep up with the buffer. Because if FramePro stalls, it stores the
Yeah.
buffer and it stores the game. So everything has to be fast. So the actual, probably the most difficult thing was the processing in FramePro to work out the hierarchy of this graph that it's showing for every frame and all the functions and where to, all it gets is a packet with the time and like an ID of where it came from. And then it has to work out where that goes in the frame and where to put it in the hierarchy of it and everything else. So there's quite a lot going on the FramePro side to
Oh,
process the data.
so is ID sort of encoding the information where it should be put, or where does FramePro get this information if it gets only ID and time?
And it gets a few more things than that, but it's been so long I can't remember the details to be
Okay.
honest now.
Okay.
But basically, it was mainly to do with the hierarchy of, because I had to move as much processing of the data away from the game and into
Yeah.
the app, if you see what I mean. Because the app
Yeah.
can just use as many threads as it like on a PC, whereas the game is trying to play a game and run the engine at a consistent frame rate. So that's what made it more tricky, just moving all of that processing. And I can't remember the details now, but it was quite tricky.
Okay. Okay. I want to also ask about the fast find. So both plugin for Visual Studio, but also the feature of like searching files in 10x.
Yes.
What's tricky about doing the file searching and content of the file searching as well, and then why in a lot of the editors it's painfully slow and you have it running like extremely fast?
Well, I'll admit there's nothing complex going on. It's the most simple, basic brute force way of doing it.
Okay.
I'll explain. Um, it was actually when I was working at Lionhead, and I think I was working on Unreal at the time, and I was spending most of my day searching for things in the code base. A huge code base which I didn't know, and every search I was doing was taking like 10 seconds. Type in something, search, wait 10 seconds, see the results. That doesn't seem like much, but I was doing this literally hundreds of times a day. To try and work out how everything worked and just searching for things basically. And at the time, I had this monster PC. It had like, I don't know, 32 cores and 128 gig of RAM, and this was like 15 years ago. This was
Okay.
a top end machine and SSD and everything. Even now it'd be a pretty decent
Oh
machine.
yeah. Oh
So
yeah.
yeah, it was crazy. And I thought, I've got the most powerful machine I've ever seen in my life. And I'm sitting there for 10 seconds waiting for it to trundle through a disk, load files off a disk, search them and close them. And I thought, what? This is crazy. And I did a few calculations. I looked at the source code, and even though it was quite a few million lines of code, it was still only like 300 or 400 meg of memory. And I thought, I've got 32 gig of memory. What's like a few hundred meg? Just stick the whole thing in memory and never hit the disk at all. Why am I hitting the disk? It's crazy. So yeah, I thought, okay, I can just shove it all into memory. And then I thought, well, I've got all these cores sitting there doing absolutely nothing for most of the day when I'm not compiling. Can I just use all of the cores to search? And I thought, wow, if I just lay out everything linearly again in memory, all cache friendly, and I just get every single core just searching through this memory, how fast would it be? And I did a few calculations, and I thought, well, it should be like 5 or 10 milliseconds to search the entire code base for something. And I implemented it, and I was wrong. It was 1 millisecond to search the entire code base. And I thought, well, that's fast enough to search as I type. As you're typing in, it's updating the search.
Yeah.
That's crazy. And the way I do it, because it's funny, because a lot of people think I got some clever algorithm to index everything and I don't at all. All I do is I break up the files so each thread has X number of files, so I just divide the number of files by the number of threads, number of cores the machine has. I load every file into memory consecutively, so I'll allocate one huge buffer for each thread, load the files into memory consecutively, and then just set all threads going at the same time. And they're all only touching their own bit of memory. They're using the read ahead cache because it's just going incrementally in memory.
Yeah.
So, the cache is saying, well, I know exactly what he's doing. He's reading all these bytes, sequentially. I'm just going to load in the next meg into the cache, and it's just in the cache. So I'm just searching in the cache. So I'm not even searching from the disk. I'm not searching from memory. I'm searching in the cache. The memory's already there. And because every thread is just reading, there's no contention. Every thread has got its own big block of memory. So there's just no conflicts between any of the buses. And it's just incredibly fast to do the brute force method. And that's all I do. So yeah, it's nothing clever.
Nice. Nice. Okay. And now it is used to both, it's a Visual Studio plugin, like a paid one,
Yes. Yeah.
and the default search engine
Yeah.
for
I
10x.
pretty much just ported it to 10x. But I have been making modifications to it since then, just adding some features and making it a bit nicer. But
Okay.
the Fast One plugin for Visual Studio is still available if anyone still wants to use Visual Studio. It makes it a bit nicer. So yeah.
What is then on the roadmap for 10x, and what is the future for you?
Yeah, well, at the moment, I'm just carrying on as I am. I'm not expanding or growing a big company or anything. I'm happy at the moment, just working on my own, plowing through bugs and adding features. That's not to say I might not take people on in the future. Things may change. I don't know. So yeah, at the moment, I'm working on new features such as, well, I've literally yesterday just finished adding multi-window support. So you can now drag windows out of the main window and put them across multiple monitors.
Do you say Windows now? Or panels?
Oh yeah, no, these are actually windows. Yeah, because
Okay.
as you probably noticed, I called everything panels in the editor. So you have one window and it has lots of different panels. Because I've
Okay.
never liked windows within windows. A window is something you look through. It's
Yeah.
not. It's like it's not a thing that is there opaque and you look at. So I call them panels. It's just a bugbear. Oh, I thought I'm writing my own UI system. I'm allowed to invent some of my own implementation.
I'm
But
allowed to do that. Nice.
yeah. But no,
So
these are
multi
actually windows. So you can
Windows.
pull out
Okay.
windows from the main window. Any panel you can pull out. It creates a new window for it. And that's
Okay.
something a lot of people have been asking for. And I've been promising it for about 2 years. And I was like, yeah, I'll work on it next week, definitely. And then more bugs come in. So, it's always easier to work on a bug than start a whole big new feature.
Do you prefer to work on a bug?
I prefer to work on features. It's always fun to write something new, definitely. But it's kind of easier to work on a bug. It's like almost an addiction. You think, oh, I can just knock off 3 bugs this
Yeah.
afternoon, and you've made progress, even if they're just small bugs, and you've made someone happy. Life is very simple being bugs, but there is a limit to how many bugs one person can do before going completely crazy. So yeah, it's great to work on features, and I want to work on more features going forwards. For example, I'd love to support more languages in the parser. Um,
Oh, okay.
so I
What
think
would
it'll
be
always be
what would be on the
it'll
list?
it'll always be a C++ editor at heart, but it would be nice to add at least some support for Python, as that is the scripting language for 10x, and also for C Sharp, because a lot of C++ programmers do also use C Sharp for tools and scripts and things like that. So yeah, I mean, there are lots of good editors for C Sharp, So I'm probably not going to compete with those, but it'd be nice to add at least some support for it as well. And I think with some refactoring and reorganization of the parser, I can make it work on other languages without too much trouble. But that would be a big feature. So yeah, I don't know
Okay.
quite when that's going to happen yet.
Okay. All right. Then with the closing words for this interview, I highly admire the work you do and the level of quality in your work. And what would you say to like aspiring developers? What would be the advice to learn to code at your level in 20 years?
That's a big question. I would say in general, forget books. Unless you're just starting out in a language, then you need to read a book to learn the syntax. But in general, I haven't found books useful personally. As I was saying earlier, write your own container classes. Use as few features of the language as you can get away with, whatever language you're using. There are lots of shiny new things. I can do this in one line and do all this clever stuff. Don't do it in 10 lines. Keep it simple. Keep it obvious. Learn from other people wherever you can. And also, I'd say don't be scared to jump into unfamiliar code, because that's something a lot of people I don't think are taught at university. They're taught to write their own basic class hierarchies, etc. But it's not something you can learn on a course if you're just dumped a sort of million line code base and you've got to work out how it all fits together and how it works. That's a real skill. And you learn so much from reading other code. So I would say just download an engine, look at the source code, and try and understand it the best you can. A lot of the work I do when I'm contracting at different companies, I'm a contractor. I come into a new company and I don't know their code base at all, and I'm suddenly expected to fix bugs in it or proof optimize it or whatever. So I have to be able to go in, and sometimes I'll just spend a couple of weeks just reading code and getting it all in my head, hold as much as I can, and then I can be useful and fix bugs and profile it and stuff like that. So I'd say to new programmers, don't be afraid, because that's the thing I learned when I very first started at Climax, was these coders weren't afraid of anything. They were completely fearless. And they would dive into any code they'd never seen before and start hacking it to bits and putting it back together again. And it was just like, how do they do that? It was amazing. And I think these days, maybe that's not done so much because a lot of programming is just bolting things together and you don't really understand the things you're bolting together. You just think, how can I make these two things fit together and work somehow? And you don't really understand what's going on under the hood. So I would say to people, read as much code as you can, learn what to do, learn what not to do, even more importantly, and fix lots of bugs, and you'll learn an awful lot from fixing bugs. I've learned more from fixing bugs on how to optimize than I have from anything else. When I see mistakes, and you spend when you've spent days trying to reproduce a bug and fix it, you don't forget that. When I spend days trying to work out horrendous complex lambda expressions in C++ with all sorts of modern C++ nonsense, and I know the person writing it didn't understand what they were doing. When I spent days fixing a bug in that code, I don't forget that. And I've learned a lot from that, and I know not to do that. So yeah, fixing bugs and reading code, that's what I would say.
What would be the good places to read the code, like the good quality code?
Oh, now you're asking. I honestly don't know, because I don't do that on the internet. Obviously, I
Yeah,
read code when I go to companies, but that's proprietary code usually, and I
yeah.
can't share that. So no, I can't think of any good sources, but they don't have to be necessarily good sources. Like you can learn a lot from reading bad code, just as much as you can from good code. Yeah, I mean, it's a really good question, and hopefully someone can answer that, but not me, unfortunately.
All right. Thank you so much. Thank you so much for joining me and this lovely deep dive into your tools, not only 10x, but all the other tools as well.
Oh, well, thank you for inviting me. It's been so much fun to share all this. It's been really good. Yeah, so thank you.
Thank you.